Hello, pre-calc students. Here we are with our last section of 11, roots of complex numbers. And the objective is to find roots of complex numbers. Now remember when we found all those roots of 64 in Review Pack 2? It was the equation solve x to the 6th equals 64. Remember that? Oh my gosh, we're in Chinese. X to the 6th equals 64. Was that not an absolute stitch employing all that factoring? Now we have an easier way. But first, for those that want to relive the pain, let's go through that so you can see the pros and cons of this new system. Here it goes. It started off with x to the 6th equals 64. And then we subtracted, thinking we could factor it. And some of you mistakenly factored it with x squared, a difference of cubes. But actually, if you look at a difference of squares first, it works out better. Because you get x cubed minus 8 times x cubed plus 8. So you get x cubed minus 8 equals 0, and x cubed plus 8 equals 0. And then if you remember how to factor a sum of cubes, a difference of cubes, x minus 2 times x squared plus 2x plus 4. And over here, x plus 2 times x squared minus 2x plus 4 equals 0. Well, this leads to a lot of roots. We get x equals 2, and we get x squared plus 2x equals negative 4. We added a 1 to both sides, so x plus 1 squared equals negative 3. Over here we're getting x equals negative 2, or x squared minus 2x plus blank equals negative 4. So we add 1 to both sides again, and x minus 1 squared equals negative 3. See how we got some imaginary roots over here? So x plus 1 equals plus or minus the square root of negative 3. So x equals negative 1 plus or minus I root 3. And from this other one, x minus 1 equals plus or minus the square root of negative 3. X equals 1 plus or minus I root 3. Well, that's quite a few. And we had the 2 and the negative 2 from before. But we put these all into an Argonne diagram now. I think you'll see some of the magic happening here. And let's tick this off as, I call that about 1, 2. So let's look at our roots. We came up with 2, negative 2, negative 1 plus the square root of 3, negative 1 minus the square root of 3. See what's coming up here? 1 plus the square root of 3, I. 1 minus the square root of 3 times I. Look at all those answers. All of them 2 away from the origin and equally spaced, every 60 degrees. Amazez-moi. Draw a line in that circle. Well, if you make the dots big enough. Now, let's write these out in polar. This is 2 at an angle of 0. This is 2 at an angle of 60. This is 2 at an angle of 120 degrees. 2 at an angle of 180, 2 at an angle of 240, 2 at an angle of 300. See, they're coming every 60 degrees. So let's reverse engineer the problem. And now, take it on this way. Think of it as a complex number. We were asked before to solve x to the 6th equals 64. What if we think of it as z to the 6th equals 64? There you go. Z to the 6th equals 64. Because we expect some complex answers. Now we could put a plus bi here to the 6th equals 64 and set up systems equations in a and b. And oh my gosh, no. Not going to go there. Okay? Get out the big eraser for that one. Instead, we're going to pick z as r at an angle theta and raise that to the 6th equals 64, or r cis theta. So we get r to the 6th cis 6 theta equals 64. Now, r to the 6th cis 6 theta, I'm going to set that equal to 64 in its polar form. 64 is 64 plus 0i. In polar, it's 64 at an angle of 0 degrees. But don't just stop there because you only get one answer. You have to think 64 cis 0 degrees plus anything coterminal with that, so that's 360 n, or let's say k, where k equals any integer 0, 1, 2, 3, 4, and so forth. Okay? So, now, we can just say r to the 6th equals 64, and just take the 6th root of 64 to get 2. That's consistent with all of these being 2 away from the pole. And further, we can say 6 theta equals 0 degrees plus 360 degrees times k. So theta equals 0 degrees over 6 plus 360 degrees over 6 times k, or theta equals 0 degrees plus 60 degrees times k. So that's how we get our answers 2 at an angle of 0. 2 cis 0 degrees, 2 cis 60 degrees, 2 cis 120, 2 cis 180, 2 cis 240, and 2 cis 300 degrees. And there are your 6 sixth roots of 64. Much easier, this approach, than all that factoring we did before. One of the other problems, too, was if we stuck to the old approach, we'd have to rely on things that we could factor. And we had some factoring tricks for this one, with difference of cubed and difference of squares. But what happens when we get to the 6 sixth roots? Oopsie, I already did that example. The 6 sixth roots of 64, we just did that. Here we go. Now, the cube roots of 8i. Well, if I set up x cubed equals 8i, I don't know how to factor 8i. But we look at it as z cubed equals 8i. And z is r cis theta. Now, you can use r comma theta or r angle theta. Or I like writing out cis to remind me that I'm in polar form. We have to get 8i into polar. And this is where a lot of kids get confused. Let's take a look here. Where is 8i? 8i is straight up here. 1, 2, 3, 4, 5, 6, 7, 8. This is 8i. It's 0 plus 8i. Now just look at it. You've got to be able to eyeball this conversion quickly and not sit there and worry about all the formulas and r and tangent and all that. Look at it. You're going straight up like that. That's a 90-degree angle, right? And it's 8 away. So r equals 8 and theta is 90 degrees. That easy. 8 cis 90. So we cube this out. R cubed cis 3 theta equals 8 cis 90 degrees plus 360 degrees times k. So we set r cubed equal to 8, and that's where we get r equals 2. And set 3 theta equal to 90 degrees plus 360 degrees times k. So theta is 30 degrees plus 120 degrees times k. So this sets up our answers then. We get 2 at an angle of 30 degrees, 2 at an angle of, add 120 on this, 150 degrees, 2 at an angle, add another 120, you get 270. If you add another 120, you go over. 2 at an angle of 390, oopsie, we're over. And we only expected 3 cube roots. So you can answer like this, unless I say give the answers in rectangular form. In rectangular form, then, you can think of the picture 2 at an angle 30. So that's 1, and this is square root of 3, so you get square root of 3 plus I. 150, you're way over here now, and you get the opposite of square root of 3 plus I. And at 270, you're going straight down, so that's negative 2I. So there are your 3 answers in rectangular form. These were the answers in polar. Now let's look at another one. The 4 fourth roots of negative 16. Again, you've got to write negative 16 in polar form. This is rectangular form, negative 16 plus 0i. That doesn't help us. Let's think of this as z to the 4th equals negative 16. So that's r cis theta to the 4th equals 16 at what angle? What angle? Come on. You're backing up this way, so it's 180 degrees plus 360 degrees times n. So r to the 4th equals 16. We get r equals 2. And 4 theta equals 180 degrees plus 360 degrees times n. So theta equals 45 degrees plus 90 degrees times n. So we're going to get our answers every 90 degrees, 2 cis 45, 2 cis 135, 2 cis at 90 onto that 225, 2 cis at 90 onto that 315 degrees. And we get our answers equally spaced around the unit circle, around the circle, like that. And if you remember, if you got 2 at an angle of 45, the sides then will each be square root of 2. As you divide 2 by the square root of 2, you get square root of 2, because it's the 45, 45, 90. So these are our polar answers. We could stop there unless I specifically say. Usually you want to give the answer in the form the original question was, and this was rectangular, so you should answer in rectangular. That's the assumption you can make unless I specifically say otherwise. So in rectangular, this is square root of 2 plus I square root of 2. This is our second quadrant one, so it's negative square root of 2 plus I square root of 2. Here in the third quadrant, negative square root of 2 minus I square root of 2. And finally, the fourth quadrant, square root of 2 minus I square root of 2 for your 4 fourth roots. Now, we can sum this up then. If you want to memorize this formula, it's fine. It's easier to do the process too, but if the nth roots of a complex number could be written in the following equation. They are the nth roots of z, so that's z to the 1 over n. So in r cis theta form, you're going to take r to the 1 over n, and then cis, you're going to take theta and divide it by n. But then you're going to add 360 degrees times k on and divide that by n to get all your answers. Where for k equals 0, 1, 2, 3, all the way up to ... n minus 1, giving you a total of n roots. Okay, flange out.